So visual geometric program. There are some tools for it. One is the Dynamo and another one is Grasshopper. So Dynamo is actually with Revit right now. So it started off as an open source platform. It still is open source. I believe you can download it yourself. You can utilize it yourself on a standalone basis. You do not need necessarily Revit for that. But it's good that right now it has been acquired by Autodesk and has that plugin from Revit to Dynamo. So essentially, if you have, let's say, an element in Revit, you would be able to export it in Dynamo, perform some work, or vice versa. You would be able to perform it in the studio in Dynamo and then export it into Revit. Grasshopper works with another software for building information modeling and design, which is called Rhinoceros. And I think it's good for you to download both of them and work with them. I believe this is where the future is, at least even as civil engineers or as project managers. I believe it is a necessary tool to at least be familiarized with. Then in these platforms, you perform something like this, which the first time that I saw this, I was like, and I'm for some of you that don't know, but the students that do know, they know that I'm not a bad programmer. The first time that I saw this, I couldn't believe my eyes what was happening. It's like, what are these? Is this like some sort of spider that is going to one after the other? However, once you get familiarized with it, it's actually quite simple and quite easy and quite intuitive, because then you can add these slider numbers. And with those slider numbers, you can slide down these values. And with those values, once you slide it back and forth, you would be able to see how the whole structure that is interconnected with each and every one of these values is going to change, which is something that just didn't exist with even with strong software like AutoCAD. And then you create a geometry based on that, and that geometry can be utilized to further your information modeling and your engineering analysis. So installation. If you want to install Dynamo, you basically go to this link. Once you go to this link, you have either the Dynamo Sandbox, which is an open source environment for you to be able to go and perform that. That is a standalone solution, or you have the Dynamo Revit, which as students, you have the opportunity to be able to download Revit, register for it. And this is the good thing about Autodesk, which has the ability for us to as students and as academic and faculty, to work with the software free of charge. So I would strongly recommend for you to download Revit at least 2019 and above. But I think Revit 2020, 2020 and after would be a good start as well. So once you download that, you have Dynamo there as well together with it. Grasshopper used to be open source. I wasn't able to see it this time. So what I was able to find that it is possible to download Rhinoceros 7 particularly. And then there is an evaluation period, essentially a 90-day evaluation period, that if you do download it by, let's say, next week, that would be sufficient enough more or less for the duration of the course. Next week or the week after, that would be sufficient enough. So it is good because we will be doing some of the parametric robot design with Grasshopper, because that would just be much easier rather than me programming it from scratch. So these are the two that I would recommend you downloading. Now, let's see what it would actually provide and what you can actually see from these, and how you would be able to utilize these types of tools. So the first is creating a point. So you have, you can, and I'm going to talk about Dynamo. Grasshopper would be similar in that sense. The good thing about these is that at its core, it is a programming tool. So meaning if you want to define a particular element, a particular item, you would be able to define it and program it inside with a library. And If you search the internet, there are thousands of different libraries that people have taken the time to actually put there, where you can install and plug it in essentially your Dynamo and utilize that as functions, similar to how we use MATLAB or other types of software as well. So for this, basically search, let's say, a particular function. Now, here I don't talk about how you can create a function because there's so many that already exist. For this course, I don't believe it is necessary. However, it is possible for you to also do that. Once you do points, there are various different aspects that you can utilize, let's say Cartesian coordinates, cylindrical coordinates, spherical coordinates, or just by XYZ, which is the same as the Cartesian coordinates here. So basically you put in point, or let's say cylinder, or whatever that exists in the libraries. If it doesn't, you can download the library and then utilize it there and use their functions respectively. Then you have your XYZ. What this suggests is that if you provide this nice box here, X, Y, and Z, it would give you a point, and it will show that point in that environment that you see over there. So what you would need to do is you need to put some sort of number there, a number that is associated with your X, a number that is associated with your Y, and a number that is associated with your Z. So you basically click on number, and this is essentially a number. This is, I apologize for that. So here, essentially what you do is you have a number, and that number you add on to that. And with that number, you can specify what that exactly is going to be. So you can specify an exact number, and you can assign that exact number, again, like this, to each and every one of these elements. And then, of course, you can copy that and, again, do the same thing there as well. So as you can see, now that number is 000, it was here. Now you changed it to 1, it jumps on 1 on the X direction. If you do 2 in the Y direction, it jumps on 2 over there. And then if it's the Z direction that you're going to change, similarly. So this is how it is. Each and every one of those nice curved basic pointers that goes from one to another, that represents the relationship between whatever it is in terms of value to whatever it is in terms of the function. And it provides you and visualizes that for you there as well. So if you have just one number, it would be a bit more challenging, right? You have one number, how are you going to change this value? What are you going to do? This is where the utilization of the concept of slider number comes in handy, where you can basically, again, go through the points. You find the point. This is by the Cartesian coordinates, for instance. You have X, Y, Z. Here, instead of having a particular point there, you have the slider number there instead of one number. And this slider number has, let's say, a range. So for instance, here, the range is from 1 to, let's say, whatever, and you can actually specify what that range is going to be as well. You basically have to find exactly here, and then you say, okay, minimum from 1 to what to 1? So from 10 to, let's say, 100. And then you can slide it, and as you can see, as you slide it, this actually changes. And you can reduce it and go forward. And then you can also add different steps. Here, for instance, steps are 0.1, whatever unit that is. So as you're sliding this, everything together changes. So this is for particular numbers. You would be able to utilize that and create that. Again, the benefit of this is that when you're creating geometry or various different numbers or various different points there that are going to be let's say a surface is going to fit in each and every one of these points, then when you're changing this, the surface is going to change automatically as well. This is a very powerful tool. So here, is creating an array of points. Now, the array of points becomes valuable for us, especially when we're creating some sort of grid system, or we want to know how it is and create some sort of function. So there are these code blocks that you can have, and these are more or less when you get more familiarized with the software. So this is one of them. You put 0, and then you put hashtag A, and then you put 1. That means that whatever that number is going to be added by means of till A in one intervals. So is from 0 to A with 1 intervals, where we basically use it twice there. We use a slider number, and then you add a code there, and you assign a value, a slider number. And if that A is basically the number of points that exist in a particular array, that would be essentially how you're going to add it and reduce it. Let's say what that means is, if you have, let's say, 20 points that you want there, you would be able to have it in, let's say, 1 increments, and then you add to the A, increase it, and then the number of points actually increase together as well. And that 1 there that you see here basically suggests to what space those points are going to be from each other. If we change it to 2, the space is going to be a bit more. Here is only 1. And then you can perform this for each and every one of them. So basically you can copy that one here, and then another one again down there as well, and assign it, let's say, to the Y. Now, you can also be able to perform it as a, let's say, cross product. That means that it's a full grid instead of a linear aspect. And then from this, you would have a set of these points that you can use, and you can change those slider numbers, and then the number of points and their locations would change accordingly as well. And this is, for instance, because we haven't specified Z, Z is going to be 0. If we do specify Z, add that as well, then it's going to be a box of grids, especially if we do the cross product. Okay, so you have quite a bit of options here. Now, the good thing is, now for your Z, you might want to put some sort of, let's say, function there. And it would basically surfaces like a perfect function with the mesh of your XY that you have there. So you might say, okay, it needs to be some sort of quadratic function. Then it will basically show you, let's say, or let's say half a circle or an ellipsoid. And then you would be able to get that particular surface from it. Okay, so, and the last thing that we are going to talk about this visual programming, at least today, because we're going to be going into a bit more detail about it next session, is going to be creating a cylinder. Now, the cylinder, like a lot of other items, is going to be pretty much similar in that regard. So you go to the cylinder. We talked about this bit last session as well. So you have the cylinder by radius and points. So again, this function particularly, there are other ways of defining cylinders as well, right? But this function likes to do it by means of the start and the end, which represents your axes of your cylinder, and then the radius. So for each and every one of these, you can define a slider number. And these sliders, that would be 7 different inputs. It could be provided by 7 different slider numbers. And as you're changing those slider numbers, everything related to your cylinder would also change accordingly. So here there's, for instance, an error because the first point and the last point are the same. Once you play around and change it a bit, then it starts providing you with an actual, let's say, cylinder. Again, this is beneficial, let's say, for more complex surfaces and shapes, you would be able to perform that. Now, once you have a particular geometry that you can create easily with these tools and play around with, especially in the preliminary, let's say in the conceptual design stages, this would be quite beneficial for us. And actually, this particular program is quite valuable because you can also perform optimization and generative design, as I will be talking about it in the next few slides as well. Okay,